Good morning, everybody. Welcome to this webinar, Identify and Handle Plant Nutrition Deficiencies. This webinar is organized by Haifa Group, Task Force Modern Greenhouses. And before we start, I shall first introduce the task force members. We have Ishai from Israel, Janus from Poland, Ampero from Spain, Dimitris from Greece, Avishai from Israel, Marco from the Netherlands, Todd from the United States, Tal from Israel, Juan Manuel from Mexico, and Vasilis from Greece. Both are not on this picture, but I think they're also in the meeting today. My name is Ronald, I'm from the Netherlands, and the presentation today of this webinar is done by Marco and Avishai. Before we start the presentation, some technical issues that I can show you on the next slide. First of all, on the right top corner, you have the chance to choose between gallery view and speaker view. And if you put on the speaker view, then you see the presentation of the speaker, and you also see his face. If you put him on gallery view, you see all the participants in this webinar. Another thing, if you have some questions, in the middle of the bottom, you have the possibility to chat, and that's the chat function. There you can put in your questions. The questions come in my screen, and at the end of the presentation of both speakers, I'm going to ask the questions to them. So feel free to ask whatever you want, and we try to answer them for you. Good, that's for my part of this. I give over the microphone to Marco to start this presentation. Marco.
Okay, thank you, Ronald. Good morning to all. The topic today is to speak about identify and handle plant nutrition deficiency. But I must say it's from a fertilizer point of view, so we shall share a lot of information, and we speak about macro and secondary nutrients, macro and secondary nutrients, but both are very important to speak and discuss about it, because without the secondary nutrients, it's not possible to manage the crop. But before we dig in, we shall present an overall view. Because we think as a task force group that we must say something about other topics which are very important. We speak about the right balance of elements. We shall say something about iron interactions, because that's also good to know where we have the interactions from the diverse elements. Of course, water and pH. It's very important to think about this kind of topics. EC is also very important, of course. And of course, also the mobility of the diverse nutrients. There we have also some information from the market, from the diverse labs in the countries to speak about it. And some words about the diverse nutrient analysis, which we do in the market. And then we shall dig in micronutrients. I shall speak about N, P, and K. And when I finished these presentations, I shall share the screen to Avishai, and he shall take care of the secondary nutrients, and he shall speak about calcium, magnesium, and sulfur. But as we managed, we shall say some words about overall view, which I mentioned in the previous slide. It's important that we have a balance in all elements which we have in the requirements. So without, for example, magnesium, it's not possible to manage a crop. So every element in the bucket, which you see on the left of the screen, must be fulfilled. Otherwise, we have a problem, and we can expect some deficiency problems in the diverse crops which we have. So the balance must be there, and also in the root zone, we are going for a good balance of the diverse elements. And when we have that organized in the root zone, then we do everything from fertilizer point to keep a healthy crop. And then we don't expect deficiency problems. If we have something wrong in the root zone, then we are going to the right of the screen, then we can expect some deficiency problems in the top or above the soil. Also, the ion interactions. It's very important to know the background of this, because when we have too much from one element, it has an effect on another element. And elements are coming from fertilizers, of course, but can also coming from water. And when we take water, for example, there's always, most of the time, calcium inside. And we see in this screen that calcium has an effect, or for example, on potassium. So you must know what you are doing from fertilizer point, but also from the water quality, which is coming in the next slides. So in this slide, we speak about antagonism, the elements which are in competition with each other. And also we have elements who are helping each other, and we speak about synergism or stimulation. But if we are discussing about deficiency problems, most of the time we are looking to this screen and we are speaking about antagonism, which elements are in competition with each other. And that's good to know, because otherwise we have some problems in the end. And this is more or less the same story. If you look on Google, on the internet, you find a lot of pictures, a lot of information about ion interactions in many pictures. And the previous slide was one. This is another one. But in the end, it's the same story. In the middle, you see the gray line, and these are all elements in general where we are working with. And we can say if we are bringing too much of these gray elements, it has an effect on the elements below, where we are speaking about antagonism. So again, if we are bringing too much calcium, you see an effect on potassium, copper, magnesium, and zinc. So with this information, if you see some things happen on analysis, or in the end deficiency problems, go back to where you are starting, look what you are doing, and try to manage the elements where you're working with to keep everything back in balance. And also I have some words about water quality, because it becomes drier and drier, also in our country, in the Netherlands, in Belgium, but all over the world we are looking for water. Water is very important, but also the quality of the water. When we are looking to our territories, every greenhouse has a basin where we collect water, which is coming from the roof in the basin. We call it rainwater, and rainwater is perfect. It's good quality. There's nothing inside, so everything what you must give to the plant, it must be coming from fertilizers, of course. So we have rainwater, which is good, but we also see more and more in the last years that when the rainwater is going down, the availability, we are looking to other sources. And okay, in the south and in the middle of the Netherlands, we are more going to well water, or if it's necessary, to top water. And then it's very important to know what's inside the water. It's mentioned in the slides which I present. Calcium is always in the water. So if we have something in the water, we can decrease this kind of elements from fertilizer point. Otherwise, we are back in competition between, again, calcium and potassium. So know the quality of the water, know the bicarbonate level, because you must also manage the pH in the end, and I shall also say some words about that. So in general, water, know the quality, and manage that in your recipe. Manage that in your requirement, because otherwise you have maybe problems in the end. Another, in our opinion, a very important thing is pH. And this screen shows you the pH in the root zone, where the plant is staying in, and look to a pH which is optimal for every element. And when we see this screen, yeah, we can conclude that the pH in the diverse crops for all elements is optimal between around 6.5, between 6 and 6.5. Every element is maximum available to make it applicable for the plant. If we are going to a pH of 7, which we see in many crops, also in our country, for example in pepper, where we have a pH of 7, most of the time, also in this period, yeah, we lose the availability of, for example, phosphorus more and more. The higher the pH, less availability of phosphorus, but also manganese. These are, we call it the pH relevant elements. The higher the pH, less availability of different elements. So try to manage the pH in the root zone. And also with that, I give you some practical tips to manage that. So how to manage the pH? We have different places to manage that, to check it, manage, and again, measure. We have an A and a B tank, of course, where we add the fertilizers. But the A and the B tank, together with drainage water, which is in our country standard, it's coming in a mixing tank. We call it also the C tank or something, but everything is coming together in this kind of tank. There we measure the pH, and this pH must be correct. Otherwise, we are sending elements to the plant, which are good, of course, but the availability is more and more going less. It's also good to check the dripper. So we expect a pH for vegetables, tomatoes and peppers in the mixing tank around a pH of 5, between 5 and 5.5. But in the end, from the dripper, I want to have more or less the same pH. And there we see that the pH sometimes is going up, or maybe it's going down. And then there is something wrong. So also try to measure and manage the pH as much as possible. And also in the drainage water. So the plant is taking up elements, but also bring some elements back, and we call it drainage water. And there also try to measure the pH, and then if it's available, of course, try to organize an optimal pH in that, because this kind of water is also going back again to the crop. For manage the pH, we have different possibilities from fertilizer points. When we speak about water, and for example, we are using well water, the only thing to manage the pH and also to decrease the level of bicarbonate is to work with acids. And in the market, there is a big availability of nitric acid. But if we are not have the availability of nitric acid, there is also phosphoric and sulfuric acid. These are the 3 types of fertilizers to manage the pH in your water quality. If we want to try to manage the pH in the slab, the only thing to do is, of course, to have a good pH in a mixing tank. And again, we do it with nitric acid. But to manage the pH in the slab, in the bottom of the screen you see slabs. The only thing to manage that is to work with fertilizers which contains ammonium and or urea. And ammonium is the most common fertilizers, the liquid or the solid one. And there we can try to manage the pH in the slab. And also the EC is very important to bring enough good elements to the crop. And for example, we see the market where we are decreasing the EC to a lower level, especially when we have hot temperatures, where we are giving a lot of water. We speak a lot of customers who are decreasing the EC with 0.4 EC or something. But no, especially in the cases where you're working with other water quality than rainwater, yeah, it's important to know that there is something in the water which is increasing the EC, and with a lower EC, it's possible that you are not bringing the good elements in a good balance to the plant. So in the left part of the screen, we can expect some nutrition deficiency if you are not in good balance together with another water quality. Also, the other part is when we are bringing the EC to a higher level, know that there is, of course, more EC coming from elements to the plants, but it's difficult for a plant to get the right elements and the right balance into the plant. So see if you can manage, and in this screen we are speaking about the optimal EC is 1.5. Okay, we are knowing that the EC is increasing more and more also to put the plant in a more generative phase. But okay, look to your market and see if you can manage that in a good way. And another important topic in this is knowing the background of the elements. We are speaking about mobile nutrients and we are speaking about immobile nutrients. And in the middle, we have some elements who are variable mobile. If we are speaking about mobile nutrients, then we are speaking about the N, nitrogen, P, phosphorus, and K, potassium, and also magnesium. And when we are speaking about these elements, we can say that these elements are mobile. So it's easily transporting from the older one to the youngest part of the plants. So knowing this theory, we can, if we have a problem with one of these elements, we can expect some deficiency problems in the older leaves. So in the lower parts of the plants. If we are speaking about immobile nutrients, it's the totally different story, of course. We are bringing this kind of elements via the root zone into the plant. And most of the time we see some problems in the younger parts. And then, and Avishai shall explain that, calcium is a very important element to manage that and to bring these elements in the younger parts of the plant as much as possible, of course. And then we have, before we are digging in on elements, we have different type of analyses to see what we are doing to manage the pH as much as possible. Most of the growers are working with slab or drain analysis. They do it frequently, once a week or once in 2 weeks, especially in this period when there is a lot of fruits coming from the plant, to see if we are on a good way. But also more and more, we are looking for more information. Are we on a good level to do the right thing? And again, slab and drain is very important to know what we are doing and what's available for the plant, of course, but also to see what's coming from the dripper. So we are collecting water from the drip. We are seeing the pH and EC, and if we are bringing this kind of water to the lab, then we have everything on paper from every element what we are seeing and what we are sending to the plant. So it's an extra control method to see if we are good on the right way. And more worldwide, we see also more and more analyses coming from the leaf, tissue analysis. And there we have the dry matter or the plant sap. And that says something, okay, we are bringing fertilizers to the plant. And we want to see if these elements are in the plant, to see if we are good on the right way. And I think this is also a step forward to see if we are can resolve the problems from fertilizer point and to see if we can manage the elements into the plant. And an example in the bottom of the screen is the value of leaf analysis. In this case, it's from tomato, but we know that there are a lot of varieties in the market. But it gives you some good direction before fruiting and during fruiting to see which elements in which level that we want into the leaf. So analysis once a week, twice. It's good to know what we are doing. So these were the most important things before we are digging into the elements. Now we are speaking about the macronutrients, nitrogen, N, P, and K. And then we can see what information we have over there. So nitrogen is like all other elements, a very important element, of course. It's a building block for diverse vital compounds. And this element is also more and more in discussion in the market. It gives you some vegetative growth, of course. That's what we want in the first stage of the plant. So we bring a lot of fertilizers which contain a lot of nitrogen to give you a good start. But there is a period coming that we want to manage the plant into more and more a generative stage. But the first part is to give enough nitrogen. And of course, there is a lot of knowledge in the market to see which level is important for your crop. But nitrogen is good for vegetative growth, plant vital compounds, strength cells, and also a compound of chlorophyll, which is important, of course, for the whole photosynthesis process. And of course, if we have some problems and we don't like it, but there is always a period in the year that we see some problems. And then the question is, okay, which deficiency is it? Is it nitrogen? Is it phosphorus? And it's good that you know how it looks like. And of course, we are speaking about mobile elements. So normally in the bottom stage of the plant, you can expect this kind of pictures where the plant is going into a yellow stage. And then you can think about, okay, maybe it's good that we are thinking in the direction of a nitrogen deficiency. And here we have some pictures showed on the screen. And of course, we have nitrogen forms from different type of fertilizers. So we discussed in the group to inform you about the availability of the diverse nitrogen forms and also about the availability of the diverse fertilizers. So ammonium, which is necessary to manage the pH in the slab. We have ammonium nitrate liquid and solid, depends on the area where you are, of course. Ammonium phosphate, MAP, we call it in the world market, and calcium nitrate. And there you see also a remark about that, because there are 3 types of calcium nitrate. But if you are working with the calcium nitrate, which contains the 1.1% of ammonia, there you have a good water-soluble fertilizer, which is containing ammonia. Of course, when we want to work on a deficiency problem which are going in the direction of nitrates, we have again ammonium nitrate, calcium nitrate, no matter which one, because every calcium nitrate contains nitrate. Of course, potassium nitrate, magnesium nitrate, in solid and a liquid one, depends on the area where you are, of course. And different fertilizers, different concentrations of nitric acid, also depending on the area where you are working with. And on the right part of the screen, we have urea, which is not very common in our country in the vegetables, tomatoes, pepper, cucumbers. But it's worldwide a big one where we can manage the pH in a slower reaction, because compared to ammonia, ammonium nitrate is direct working about pH in the root zone. And urea is gives you a slower reaction. But in the end, you give also nitrogen, because it's pure nitrogen. If we have a problem and it's visual in the plant or on paper, analyze, we can manage that from fertilizers, of course. Look to your reports from the labs and see if there are some elements above the reference levels, in this case, chlorine and sulfur. Most of the time, when the level of nitrogen on paper is very low, the other part is that chlorine or sulfur from water or from fertilizers, it's going to a very high level. So try to manage these 2 elements to a lower level to get back enough nitrogen. And that is also to do with interactions lower level of chlorine and sulfur gives you some extra availability of nitrogen. That's what we see directly on paper when you are working with. Phosphorus, that's the second one which took us. It's also a very important element to give you enough energy into the cell, but also to give you a healthy and basic root zone, because this is an element which gives you in the root zone, in the slab or in the soil, a good, healthy, strong root zone. But also for the membrane, the development of different functions, of course. And of course, it's an element which is gives you actually growing points of a plant. Without, you see immediately problems with it. I give you some extra information in the next slide, because this is one of the elements we have some problems at the diverse pH levels which we see in the market. Also here, is it mobile or immobile? Well, also what we learned in one of the first slides, we learned that phosphorus is also one of the elements who is transportable very, well, not very, but mobile into the plant. So must we look to the upper part of the plant or to the lower parts? This gives you some information about, okay, how does it look like? Leaves are becoming dark or a little bit brittle, and then you have some information to dig in. If we have to manage the phosphorus in the fertilizer and make it back available for a plant to destroy the deficiency problems in the plant. So, as mentioned, phosphorus, it's a difficult element, which is very feeling for the pH. So make it good available, make the environment where a plant is staying a good pH management. So that was mentioned in the bottom of the screen, monitoring and check and manage that, of course. And when we have a pH of 7, what's mentioned in one of the first slides, again, try to manage it with some, not too much, but some ammonium fertilizers, and bring, if it's available, if it's possible, of course, some polyphosphates into your recipe. I say some words in the next slides about that. And we also know, that's mentioned in the top of the screen, especially in the beginning of the season, when we are working with a lot of nitrogen, when we are working with a lot of calcium to bring the plant up in a vegetative growth, we are also playing with a higher EC level normally, and we don't forget, and we forget that calcium and phosphorus are relatively easily reacting with each other. And also there are some words in the next slides when we are speaking about polyphosphates. So which fertilizers are available when we want to increasing the phosphorus levels in the fertilizers? Of course, there is MKP, the most common fertilizers in the greenhouse market in our territory. But I know there is also a big market for MAP, monoammonium phosphate, which we have available for the ammonium source. But knowing that, we have also phosphorus available in this fertilizer. To manage the pH in the water, and maybe it's a combination, manage pH in the water and also to bring it in the recipe as phosphorus ingredient is, of course, phosphoric acid. It's mentioned in the middle. And on the right side, we have the polyphosphates, which there are available. Basic in the recipes is MKP or MAP, and we are giving a little bit of polyphosphates with the benefits, which I shall mention in the next slide. So one slide of polyphosphates. Again, we know that there is relatively easily a reaction coming into the system when we have a lot of calcium or magnesium available in the water. And we know that this kind of elements are very easily reacting with phosphorus. And if we want to get this reaction back available for the plant, yeah, we must want to decrease the pH level. And that's not what we want, of course, but behind there is a crop with roots. So we are a little bit limited to do something in that. If we bring some polyphosphates in the recipe, we know that the reaction is coming, but the benefit of polyphosphates in the market, that this kind of reactions are hydrolyzing in the end. So we bring back available calcium, magnesium, and phosphorus, of course, available in the root zone where the plant is taking up this kind of elements. So more and more we see this kind of activities in the modern greenhouses worldwide. No matter which crop is behind, the goal for this is to bring elements fully available for the plant. And that's one of the benefits of the polyphosphates. On the right screen above the bags, you see also keep the irrigation system clean. And also there we see some activities in the market where we are bringing a low amount of polyphosphates in your recipe, automatically direct you clean your system against mineral precipitation. And that's also one of the benefits, because we want to bring all elements to the plant. Potassium, of course, it's also very important to get a good regulation of CO2 and closing of the stomata. It's the left part of the screen, of course. But it's also good for a healthy quality of the fruits, mentioned on the right bottom on the screen. And there we see also that we are playing with potassium, depending on the period where we are. When we are in spring or in autumn, most of the time the levels of potassium are going to a higher level. And in the summertime, when we have hot temperatures and we are giving a lot of water, up to 10 liters each square meter, then we are decreasing the potassium to give also enough other elements like calcium to the plant. But potassium is also a very important element to put also the plant in a generative action. To know how it looks like if we have a deficiency problem which is going into the direction of potassium, here also you see some pictures in which direction. We learned in the first slide that potassium is also very mobile, so we can expect some deficiency problems in the oldest parts of the leaves. So if you have this kind of problems in the upper parts of the plants, it's most of the time nothing had to do with potassium. In the bottom, you see in this picture some tomatoes, and also in spring and in autumn we learn more and more, it's depending on the variety which you have, of course, that we have problems with less potassium available, that the fruits are not coloring to a good direction. Look to the numbers on your analyze report, try to manage the potassium, of course, and to see where the problem is coming from. And maybe you have some calcium too much available in your water distribution. So this gives you a good overview of the different deficiency problems in the direction of potassium. So if we have a potassium deficiency, look to the numbers on your analyze reports, know the water quality, of course, and look if you can manage some things from fertilizer points. And most of the time, when we have less availability of potassium, most of the time we have more than enough calcium and or magnesium available in the total water distribution. So try to decrease this kind of elements to bring again extra potassium available for the plant. It has all to do with a balance. So try to see where the problem is coming from and try to manage the requirement of the different fertilizers. And also here, worldwide available potassium nitrate, MKP, which is in the requirement for the phosphorus, but knowing that also potassium is inside this fertilizer. And on the right screen, we have the SOP, potassium sulfate, which is also growing in the market to put the plants more and more in a generative action. So what we see more and more, decreasing nitrogen and bringing up some other potassium-based fertilizers, which in this case contain sulfur instead of nitrogen. Again, back to the left one, we have two types of potassium nitrate available. The most left one is the standard, the Multica GG, which is very good, of course. But the difference between the blue and the yellow one is, or the orange one, Multica Reishi, is the level of sodium. And in general, we want to focus on fertilizers which contains a low level of sodium. And this is the difference between the Multica GG and the Multica Reishi, because the sodium level in general is very important to keep it as low as possible, because when we have higher level of sodium, it's difficult to bring the good elements into the plant. That's the reason why I mentioned this very shortly. So I give the word to Avishai, and they can speak about the secondary nutrients. I shall stop sharing my screen.
Thank you, Marco. Good morning, everyone. I'll be talking about the secondary macronutrients, although they're not of less importance to the plant. Every nutrient, like Marco said before, is very important, and a plant could not keep growing without one of these elements as well. So we'll start with calcium. Calcium actually is a very important nutrient for the plant. It's part of the cell walls. It's a component of the membrane, and of course, it has to do a lot with the quality of plant and fruit. A typical symptoms of calcium, since calcium is not a mobile, it's a non-mobile element, you will find them on the fruits, the very familiar blossom end rot, which appears in main vegetables like pepper, tomato, and eggplant. You can see it on the left side of the screen. And of course, since it's not mobile, you will see it also on the edges of the growing parts of the leaves. You can see this is a young strawberry leaf. It has necrosis since it does not receive calcium. What are the causes of calcium deficiencies? So the main cause of calcium deficiency, of course, it's its availability. Since calcium is not a mobile nutrient and is uptaken by the plant through the water flow, that means that conditions that impair water uptake, like high transpiration, for example, and low transpiration, will impair calcium uptake. This is on the right. You can see an example of what happens when transpiration rates are very high, when it's a high evaporation, a very hot day, low humidity. Calcium is uptaken by the root with the water flow, and since the leaves transpire a lot, the water flow goes directly to the leaves, and calcium goes directly to the leaves without going into the fruit. And this can cause, for example, blossom end rot. So it's very important to note the weather conditions when dealing with calcium. And of course, if you have different weather conditions that interfere with water uptake, you will notice calcium deficiency. So since calcium is not immobile, it will not go from the leaves directly to the fruit. It will stay in the leaves, and if we don't adjust the way we supply calcium to the plant, we will have a blossom end rot on the fruits, and this will cause, of course, a decrease in yield and marketable fruit. How can you correct calcium deficiencies? So first of all, calcium is a cation. And like Marco stated before, cations compete, have antagonism with each other. So you have to look at your water analysis, or what you give in your feeding solution, and to see what are the ratios between the different cations. If it's necessary, you can decrease the other cations like magnesium, potassium, and ammonium, of course, to increase or to decrease the antagonism of both of the cations. And of course, to increase calcium level in your feeding solution, although it will not always solve the problem. Increasing the calcium concentration may not solve the problem if we have other conditions that impair uptake of calcium to the plant. And of course, assure good water distribution. That means that Marco talked about the EC. If the EC is too high, it may cause calcium deficiencies. Sodium is also a big, has a big effect on EC and the uptake of cations. A good solution for supplying efficient calcium to the plant is by foliar application. Although it's common in not all markets or all places like greenhouses and modern greenhouses, they don't apply calcium for foliar application. But it's very common in other markets to apply calcium through foliar application. Of course, if you apply foliar application, you have to make sure it's applied correctly in the right time. And another possibility, and it's a very good one, to apply calcium during nighttime where there's not a lot of transpiration, and just root pressure will make sure the calcium is uptake to the right parts of the plants. The calcium fertilizer used, let's say the most common fertilizer use of calcium is calcium nitrate. Of course, we sell a couple of types are available of calcium from Haifa. We have the calcium nitrate, the standard calcium nitrate, which contains, if you can see right here, ammonium. And we have the calcium nitrate, the Haifa Cal Prime, which contains a minute amount of ammonium. So if you do not want to have ammonium, or you want to better control the ammonium supply to the plant, you can use Haifa Cal Prime calcium nitrate. Of course, it has a higher calcium level and a good ratio between calcium and nitrogen. One of the problems with, one of the difficulties with supplying calcium is that you must supply most of the time nitrate together with calcium. And if you have a low nitrate to calcium ratio, it's better to use it to lower the nitrate concentration. The next nutrient is magnesium. Magnesium is a very important nutrient. Since it's part of the chlorophyll. Without it, plant will not be able to use chlorophyll, of course. And you will see, I will show you the next, you will note the chlorosis. So if there is no magnesium, there is no photosynthesis. And magnesium also is involved with a couple of enzymatic reactions to generate energy. Well, will you note, when will you see magnesium deficiencies? Of course, magnesium is a mobile nutrient, so you will note it on older leaves since it is mobile, and you'll see intervenial chlorosis between the veins of the leaves. You'll see at the beginning, just beginning, and at the end, you will see a chlorotic leaf with intervenial chlorosis. Of course, if the deficiency gets worse, it will go to the rest of the plant. But for the beginning, you will find it in the older leaves. Fertilizers that supply magnesium are very common is magnesium sulfate, which is Haifa's Bittermag, magnesium nitrate, and of course, we have available some formulated enriched formulas of NPK enriched with magnesium that can be used just together, NPK with magnesium, to supply the plant all it needs. Magnesium deficiency are very common, of course, if we supply not enough magnesium, but like calcium and potassium, magnesium is a cation. And there will be antagonism if we have high amounts of the other cations in the solution, the feeding solution. So again, you must check the analysis of your feeding solution to see if there's a right ratio between the different cations. Another important thing to take in mind is the possibility of magnesium to precipitate with phosphorus. This was mentioned before. We must keep the pH of the tank below 5, so we won't have precipitation of magnesium will cause magnesium deficiencies and might cause phosphorus deficiencies as well. Like calcium, magnesium can be applied through foliar application with very effective result. If you need a fast correction of the magnesium deficiency, it can be applied through foliar application with magnesium nitrate, and this can be very effective to correct deficiencies. The next nutrient and the last, let's say, macronutrient is sulfur. Sulfur is essential for chlorophyll synthesis. Of course, it's some of the amino acids, the very important amino acid, contain sulfur. In plants which produce oil, it's a very important plant of the oil synthesis. And with the right concentration, it's essential for nitrogen uptake. Since sulfur is a, let's say it's not a really non-mobile, but it's less mobile element, you will see deficiencies on the young leaves. It can easily be confused with nitrogen because it has the same appearance of, let's say, overall chlorotic leaves. So the thing you must note is to see where exactly on the plant you will see the deficiency. If it's a young plant, it probably is a sulfur deficiency. And another thing that happens is the plant is retarded. The retarded growth of the plant system doesn't have sulfur. Sulfur comes, let's say it's a very available, or it comes in another forms. Irrigation water may contain sulfur. It depends what is the source of the irrigation. A lot of fertilizers that we use, mineral fertilizers that we use, contain sulfur. Potassium sulfate, for example, contains a high amount of sulfur. We have the potassium sulfate, the bio, a Haifa SOP bio. It's actually a special kind of potassium sulfate that will not decrease the pH in the tank solution. Magnesium sulfate contains sulfate, sulfuric acid, and ammonium sulfate. All these fertilizers contain a big amount, a high amount, or let's say a high ratio of sulfur. That's why most of the time we see sulfur in a bit of an excess in the fertilizer solution. And we don't see a lot of sulfur deficiencies because sulfur is supplied together with a lot of nutrients in the plant. So this is why we don't usually see sulfur deficiencies. And of course, we have the NPK fertilizers that supply sulfur. Sulfur management, first of all, the optimal sulfate concentration is 50 to 128 ppm. Sulfur is available in a wide pH range, like you saw in the beginning that Marco stated. You see there's high availability of sulfur along a big range of pH. Since plants tolerate a high level of sulfur, it's not a problem to give an excess sulfur. This is why can we apply a lot of sulfur and don't have really toxicity symptom with sulfur. And as we said before, sulfur facilitates an uptake. Now, if you do get a sulfur deficiency, you can do some action in order to correct it. First of all, sulfur, like calcium, like magnesium, can precipitate with calcium and phosphorus. This is a very thing you should avoid, mixing calcium together with sulfate, because then you get gypsum, which will clog the dripper and will cause a lot of problems. Of course, you won't have calcium and you won't have sulfur. And another thing you should note is when mixing sulfur together with potassium, that might be a chance to create potassium sulfate, which is a bit less soluble than other fertilizers. This is to get to this problem, you have to use really high concentration of sulfur, but this is something to be noted. That's it we went over all the macro and the secondary nutrient. This is just a few things I think that are important when we deal with nutrient or nutrition, plant nutrition. So first of all, the best thing to do to deal with plant deficiency is not to get there. So regularly monitoring soil, tissue, and water should be enough to know what is your current situation of nutrients and if you supply enough nutrients or not. Another very important thing to know when, of course, growing plants is to know that the nutritional requirement will change with the growth stage and, of course, the climate. For example, nitrate might be uptaken very, very fast if it's very, very hot. Like Marco said, for the generative growth stage, potassium is needed with a high amount, so we have to supply it. And of course, if you have a fertilization program, follow it. Make sure you give the exact amount. Don't deviate from the program unless you have to adjust according to the changing environments and the growth stage. And if you have different analyses that say, okay, we have to increase some nutrient or another, you can adjust the fertilization program. And the most important thing is to make sure you have the condition that are optimal for nutrient uptake, because you might supply all the nutrients exactly like the fertilization program, but maybe the pH is off, maybe the irrigation is not the right way, maybe the EC is too high, and this might impair plant nutrient uptake. So it's very, very important to maintain optimal conditions. So it's a big, let's say, parameters that will come down to plant nutrient uptake. And this is the presentation from us. Thank you very much for listening. You can, now I'm passing it to Ronald again to handle the question part. Ronald, please.
Thank you very much, Avishai. A lot of questions came in. We're going to try to answer a lot of them, but I already see that we, because of the time, that is not able to answer all your questions. We keep the screen that you see now, we keep it in front. There you see the address of Joshua. If your question is not answered, please send an email to joshua.golovaty@haifagroup.com. Mention in your email question for the task force, and Joshua take care that the question is sent to one of the task force members, and we come back to you via email with the answer on your questions. For now, I have a few questions that I put together. First of all, a question from Marco. It's a question from Alassane, and also a question from Danny. Marco, is there a difference in leaf analyze in different varieties? And Danny was asking, is there a preference for plant sap, plant juice, or dry matter analyzers?
It's a good question. As mentioned in the presentation, we have a lot of varieties of tomatoes, and in general, we have more or less the same reference levels that we want to see. So I think it's on this stage, because it's relative new in the market, that we cannot split the diverse varieties. So in general, when we are looking to tomatoes, I think we are looking to one reference level, and of course we play a little bit with that, but I think it's too early to say some words about that. But okay, we can dig in and we shall learn in the future. The other question is, do you prefer plant sap analyzers or dry matter? Our experience for this moment is that we have a lot of information from plant sap analysis, because this says something about the mobility of the diverse elements, like potassium, for example. And if we have an analyze method of dry matter, we have all information which is inside the plant. But with this information, we cannot say, okay, how many ppms are mobile, yes or no. So it's a robust method, the dry matter, instead of the plant sub analysis, which gives us the information which elements are inside, of course, and which are mobile. So every analyze method has its benefits or its disadvantage, but we have a lot of experience with plant sub in this case. Yeah.
Thank you, Marco. Then a question for Avishai. There are actually two questions. Can you elaborate on fertilizer effect on plant resistance on various pests and diseases? And another question was, can you direct the influence on blossom end rot with calcium? It was a question of Nayas.
Okay. First of all, regarding your first question, of course, supplying enough, the adequate amount of calcium and sulfur, as we know, can, let's say, give an advantage to a plant in order to have less diseases. But in general, keeping the amount of nitrogen a bit lower may also help on this. But this is a general, let's say, statement, because the exact amounts and the exact concentration of each one of the elements differs from plant to plant. But I think you can say that generally that the application of enough calcium can give a plant better resistance to diseases. Second, what was the second question again?
The effect of calcium on blossom end rot.
Okay. Actually, calcium is a very important nutrient for the growing parts of the plants. And since a fruit is a rapidly growing part, if you look at the vegetable part of the pepper, tomato, eggplant, these are the most common vegetables or most common fruits we see, vegetable we see the blossom end rot in. So if we have a problem with calcium supply, like in high transpiration, where most of the calcium goes to the leaves and do not go to the transpiring leaves and that do not go to the fruits, you will see blossom end rot in the fruits. This is because this is a very rapidly growing fruit. For example, the tomato, pepper, and the eggplant grow very, very fast and must be supplied with an adequate amount of calcium. So if we don't supply, or if there is a condition that makes calcium supply less efficient to the fruit, we will have blossom end rot.
Okay, thank you, Avishai. I have a next question for Marco. It's a question from Uta. You were talking, Marco, about pH in the slab. What medium are you talking about? And can urea only be used in soil growing? Because microbes are not available in substrate to break down the urea. And combined with this, I also have a question about the pH of the first dripping water in the morning, that it's sometimes very low, and is there a possibility to avoid it?
The first question was the most optimum pH in the slab, right?
Yeah, that's right.
Yeah.
No, the question was the pH in the slab. You mentioned this,
yeah.
But what kind of medium are you talking about?
Okay.
And is there a difference?
Yeah, medium. The lowest level about pH, I think it's let's say 5.5, 5.5. That's the minimum in our opinion. I think lower than we have other problems. I think also to do with some availability of diverse elements. So try to manage that to a pH of 6, of course. But the minimum, in our opinion, is around 5.5. The second question was something about urea, which is mainly using in soil growing. Yes, I think. Less using in slabs, rock wool, because we we want to know when we get the result of fertilizers, of course. And I mentioned it in the presentation also. We want to try to manage the pH in the slab, and if we work with ammonium nitrate fertilizers, we have directly an effect normally. And urea, it has to do with microban and also with the different environments, pH, sorry, not pH, the climate in total. So that's the reason why we don't like urea in soilless growing. And then was there another question or not? Sorry, I forget it.
Yeah, the pH of the dripping water in the morning. The first time you give water, sometimes the pH is very low, and can you do something about it?
Yeah, and then I must go back to what I mentioned a few seconds ago. We also learned that the first dripping water in the mortar in the morning are going to a lower level. So we want to manage the pH to the plant in the direction of, let's say, 5.5. But the first dripping water, when we collect that, sometimes we see that the pH is going to a level of 4. And when we do it the whole year around, we see in the end that the rockwool is gaping a hole around the dripper. So you dissolve the rockwool. So that gives us the information that sometimes we are giving water with a too low pH. Yes, we see it. And if we can bring some answers to that, I think you must look into the system. I think there is also some organic material inside who brings the pH to a lower level. So there are some possibilities to do something. One of them is to work with products who are destroy the organic compounds in the system. One of them is hydrogen peroxide, for example. But the other part, and then I must go back to my previous story a few seconds ago, is to work with some urea. And urea is one of the products, in the end, it decreases the pH, but the first stage from urea, which is no EC giving, is to bring up the pH. So when we are giving 2 or 3 kilo each cube of fertilizer tank, it gives you in the beginning a higher pH, and that's what you want in this stage. So there are some possibilities to manage that.
Okay, thank you, Marco. In the meantime, I got a question from Ira Matsa. I hope I say it in the right way. If we're going to share the presentation after this webinar is recorded. After the webinar, after a few days, you get an email with a link that you can see the webinar again when you want to have it. In the meantime, in the evening, this evening, we do the second time the same webinar. So if you have colleagues or you missed the beginning of the webinar, you are welcome to join us also in the evening session. We'll start at 5 o'clock Amsterdam time. What is 6 o'clock Israeli time, and I don't know the other time zones. To finish, I have for both, I have one question left. I have a lot of questions left, but for both, I'm going to ask you one more question. Avisha, a question from Monica. How can foliar application helps calcium uptake in fruits?
Okay, that's a good question. First of all, since calcium is not mobile, you must apply foliar application not 1 time, not 2 times, even 3 times, let's say, week or 2 week time. That's why it's not mobile. But when you apply calcium through foliar application, it will go also through the cuticle into the root, into the fruits, or into the areas of the fruit, and will go directly to the fruit. And that way, it will prevent the calcium deficiencies, because you apply calcium directly, of course, soluble calcium directly on the fruit tissue, and it will be absorbed to the fruit and the surrounding of the fruit, and that way you can prevent the calcium deficiency. But it's very important also for leafy vegetables as well, because it's in the growing parts. They are small parts, and they don't uptake calcium through the water flow. You have to do it a lot of times and not only once.
Okay, thank you, Avishai. Last question for Marco. And actually, there are two questions, one from Encase and one from Odette. First from Encase is, can I mix polyphosphate with calcium fertilizers in the same tank?
Yeah.
And you mentioned two types of polyphosphate. And what is the difference and when to use which one?
The first question, can we mix polyphosphates in the same tank as calcium? The answer is no, it's not possible. When we have fertilizer tanks, which are most of the time concentrated, we have, in the one part, we have calcium-based fertilizers, and the other side, we have sulfur and phosphate-based fertilizers. So also MKP, but also polyphosphates. Yeah, we must separate it in different tanks, because otherwise we have problems in the tank, and that's of course not what we want. So the answer is no. Then the second question was the polyphosphates, right, Ronald? Yeah.
Yeah, you mentioned two types of polyphosphates, and what's the difference and when to use?
Yeah. We mentioned two polyphosphates in the presentation. It was Vita-Phosphate and the GrowClean. Both contains the same polyphosphates inside, but the Vita-Phosphate in this case contains 100% of polyphosphates, which we bring into the requirements, which we bring in the recipes for a healthy crop to make all elements available where necessary, of course. It's a very unique fertilizer, so there are some rules to manage a good stock in your recipe, of course. So also there, when you have questions, please send your interest into this to Joshua, because yeah, this is Vita-Phosphate with the benefits which I mentioned. The other one, the GrowClean, contains also polyphosphates. And I also mentioned that in the presentation, because more and more growers want to have also a clean system. And we learn from the market that there's also some participation from different elements, calcium with phosphates. And the GrowClean, the word is inside, clean. When we are bringing this product into your recipes, it cleans automatically the system. So in the one part, we have Vita-Phosphate, which is giving you a healthy and a crop with all elements inside. That's the goal for this part. And the other one, the GrowClean, is in the recipe for cleaning systems against mineral clogging. Yeah.
Okay, it was the last question, but this question came in just now from Ben. Can you add too much polyphosphate?
It's always a question of which goal do you have when you work with polyphosphates. Do you want to have polyphosphates to stimulate the vegetative growth? But also there we see benefits from the polyphosphates. So if you don't like too much vegetative growth, then the answer is yes, you can give too much. So try to find a balance, or contact one of the members of Haifa to see what is the goal. That's the first question. And the second one is, okay, then we have some direction to give you the good advice. But okay, there are some rules about that. Yeah.
Okay, regarding the time, I want to close down this webinar. I want to thank everybody for participating in this webinar. There are a lot of unanswered questions. Please send them to Joshua, and we're going to answer them right away to you. Also was a question about representative of Haifa in Africa. Please send the question via email, and we bring you directly in contact with the right persons who are responsible for that area. Last thing I want to say is please join us on the second part of this webinar next Wednesday, where we're going to talk about the micronutrients. So please join us, and thanks for watching, and have a nice day. Thank you all. Bye-bye.